Let's look at the summit problem and some of the things I saw with regards to Polya's four-step problem-solving process. So here's the problem again. This one's pretty dense. I'll go over it in a second here, because actually one of the hardest things that I noticed was students had a lot of trouble understanding the problem. Students weren't able to parse everything, or if they did parse everything, they didn't remember it all. Really, you've got to take this one piece by piece, and I really recommend listing out all of the conditions in the problem. I did that here. So notice we've got 15 representatives from the United States, France, Britain, and Germany. So U plus F plus B plus G equals 15. We've got each country set a different number, so U, F, B, and G are all unequal to each other. Each country is represented by at least one person, so U, F, B, and G were all at least one. Britain and France had 7, so Britain and France had a total of 6. I would have gotten that. Had an issue there, I would have had to reread. So B plus F equals 6. France and Germany sent 7, so F plus G equals 7. And I want to know which of U, F, B, or G sent 4. Okay, so to understand this problem, really breaking down all of the little pieces and listing them out some way, whether it's algebraically, kind of like I did, or using words, or just some sort of note to yourself that these are the things to keep in mind. The number one thing that I saw in incorrect solutions was people telling me that some of them were equal to each other. That was the main number one flaw. I see that I can't save on this because I opened it from a weird place. Anyway, that they were all unequal. I got a lot of solutions saying it was Germany, and that made Britain and France both 3. They couldn't have both been 3 because all the numbers were unequal. So really understanding the problem was one of the trickier parts that I saw looking at the things my students gave me this time. If you looked at my plan, I used exhaustion. There were only 4 possibilities. Either Britain sent 4, US sent 4, France sent 4, or Germany sent 4. If you run through each of those 4 possibilities, the only one that works with our setup is France sending 4. The most popular heuristic was guess and check, or trial and error. I've got a lot of lists of possibilities where people try to figure it out, lots of crossed out things, which is great for trial and error. There's a beautiful sketch with some flags, but lots of trial and error. Really just working through what are my possibilities, and working until you find the one that's right. I also saw some organized tables. A lot of people used Excel to try to list out their possibilities. I really like what this student did where they had the B, the F, and then those two together being 6 above that. That's really nice. And then the total 15, so it's kind of got some of those list pieces there while they were making their table. Exhaustion's what I did. I had a couple students do exhaustion where they went through all the possibilities to see that France was the only one that worked. Other things, I think guess and check was really the way to go here. Somehow or another, you had to go through all the possibilities. There weren't enough in the equations for you to get an answer. You couldn't find the answer unless you had that extra piece that they were all unequal and that you did a little bit of guess and check. Really, if you were trying to prove this to someone, to have a complete answer, you should have made sure that France was the only one that worked. So just guessing that France sent 4 and then seeing that it does work isn't enough for like a full solution. Of course, that's not quite what I'm going for here. I'm just hoping you show me some of your work and how you got there. But really, if you wanted to prove this to somebody, you should show that France is the only one of the 4 that works and why the other 3 don't. And really, I saw a bunch of people use more than one heuristic. That is totally normal. It's very common when you're solving a problem, whether it's really complex or really straightforward, that you're going to use more than one heuristic. You've got to pick one to get started, but I'll go through a ton of heuristics depending on how complicated the problem is. And when I break a problem down into a simpler problem, that simpler problem I'll use a heuristic on. Then I may need a heuristic inductive reasoning or something to come back. So using a bunch of heuristics to solve a single problem does make sense. It is pretty common. So if you used a bunch and you're like, I'm not sure which one I used, that's okay. It's okay to kind of pick your best one or pick one that you know you used, but be aware that it's totally normal to use more than one heuristic on a problem. So remember, our last step is always looking back and examining the answer. Here, you should have been able to check your result. You should have made sure your result made sense. You should have made sure your result fit all of the criteria in the question, not just the equations you'd written. You should have been able to see why your argument worked, and maybe that means when you went back, you should have checked a couple more to make sure that it couldn't have been Germany or it couldn't have been the United States. Could you get there a different way? Could you see the solution at a glance? So after you had done it, do you know how all the pieces fit together? After you've solved a problem, you should really be at a level of understanding with it that you can look at your solution, close your eyes, and talk through your solution. Can you use the resulter method on new problems? Or on other problems? Have you learned anything new? One of the unique properties of this problem was you can easily write equations, but equations aren't enough to solve it. Another unique property of this is really once you understand it, guess and check or using exhaustion are perfect ways to solve it because you know all the possibilities. Here's a couple problems that I thought were similar to it. George is waiting in line at a hardware store to buy the letters to spell his house number. By luck, there were 3 customers in front of him all doing the same thing. The first customer buys O-N-E and pays $2. The second customer buys T-W-O and pays $3. The third customer buys E-L-E-V-E-N and pays $5. George wants to buy T-W-E-L-V-E. How much does he pay? So it's my claim that you can solve this problem in a similar way to the way you solved the other one by somehow working with equations and somehow working with the information in the problem. Here's another similar type of problem, at least I thought. An evil king has devised a way to drive off suitors of his fair daughter. He has placed 3 boxes on a table and placed her picture in one of them. The first box is gold and is inscribed, "The picture is in this box." The second box is silver and is inscribed, "The picture is not in this box." The third box is lead and is inscribed, "The picture is not in the gold box." The king then gives would-be suitors the following directions. Only one of the inscriptions is true. If you choose a box with a picture, you may marry my daughter. If you choose a box without her picture, I'll have you executed. Which box has the picture inside? Okay, so again, I think you can tackle this problem in a similar way to the way that some of you tackled that summit problem. Just remember, as you're looking back, always examine those possible solutions, look back, make sure you understood the problem, that your solution fits every one of the criteria, and that you actually did all the criteria, that you actually took all the criteria into account. And finally, remember, multiple heuristics on a problem, totally normal. If you find yourself starting with one, using another, and then going back, that's a totally normal and organic thing to happen when you're problem solving. And the better you get at it, the more heuristics you have in your pocket, the more likely you are to use more than one of them.